So grade 8 natural science, densities of term 2, densities of different materials, particles. That's what we were discussing about, different materials. And the last time we were talking about the density of, if you remember, density of different objects, okay? And then we said that if you take the same volume, the one with higher mass will have more density. If we take different volumes and the same mass, the one with higher volume will have less density, okay? That's what we discussed. And then that's where we stopped in the previous class. We said that if you have the same particles, is it possible to have different densities? Yes, one example is the phase change. Imagine that the phase of the same particles is changing from solid into liquid into gas. I'm not going to talk about H2O, okay? Ice, water, and the steam, because it has a different property. That's what we discussed in the previous classes. If you have any questions regarding this, please refer to the previous classes, okay? And then you can see why the H2O is different. For example, you have mercury, okay? I'm just giving you an example, mercury, okay? And then imagine that if you cool it down enough, it's too cold. I'm not talking about the room temperature, too cold, like below 0 degrees, okay? Like 100 degrees below 0, okay? Celsius. And then you see that it is in solid phase, and that's what you can see, the particles of the mercury when the 4 particles here, okay? The same 4 particles, look at those same 4 particles here. Okay, the same 4 particles, when it changes into liquid, what happens? They move faster because they absorb energy from outside. They have higher kinetic energy. They move faster. If they move faster, vibrate faster, they start moving away from each other, and there will be more space between them. They will occupy more volume. If they have more volume, what happens is that same particles, same mass, more volume will cause lower density. So which means that generally what we have, if a substance changing from solid to liquid, density decreases because particles moving away from each other and they occupy more volume, more space. And when I look at the same 4 particles here, okay, this is the same 4 particles, okay, and can you see the huge space between them? Can you see this huge space between them? Why? Because you apply more energy, okay, which means that you supply more energy, particles absorb this energy, change it into kinetic energy, and they move faster, start moving away from each other, like nothing holds them together to each other. And imagine that if you have a gas in a container, when you open the container, what happens? It spreads around the air, okay? Or that's what we call it diffuses. That's why if somebody, I gave you this example, if you remember, it was also in the test. And when I start cooking in the kitchen, and if you are in your bedroom, and then what happens is that the first thing that you get is not the sound actually, okay? You don't understand your mother is cooking, for example, bean curry or chicken, okay? How do you understand that? By smell. How do you get the smell? Because those steam particles coming up from the food, okay, it's going to diffuse into the room first and diffuse through the hole and to the other rooms. That's how you can get the smell, okay? That's what we call diffusion. Okay, what happens is that gas particles spread around between each other. That's what we call as diffusion, if you remember. It was one of the questions in the test. And what I'm trying to say here is that if generally, this is general, not for all substances, okay? We discussed the H2O example, water molecules, okay? It's totally different. So if a particle changes from solid to liquid and liquid into gas, so what we are expecting is that, so the particles are going to have different densities. Particles are going to have different densities, okay? Particles are going to have different densities. So when we look at some materials, we can also compare the densities of particles like this. We can also compare the densities of particles like this. A material which has lower density will float on a liquid, which has higher density, for example, oil, lower density will float on water. I'm not going to confuse you by giving these 2 examples together. I just want to give you the first one. Imagine that you have solid objects, solid particles. And what do? You take the same size from each of these materials, same size, like this, cubes. and it's completely the same size, 1 centimeter, 1 centimeter to 1 centimeter dimensions, okay, cube. And then imagine that you take tap water, same tap water, and the same level of tap water, you put all of them into the same level of tap water. This one sinks. That is why it takes the space of water. That's why this one is higher. And then the second one is higher than the first one because these particles, okay, of the object takes the space of water and pushes up, okay? That's why the level is changing. It's actually the same amount of water before we put. And you put the particles, okay, that doesn't dissolve in water. And then what happens is that, so one is going to float, okay, and the other one is going to float and then sink more than the first one. And the last one is going to sink completely to the bottom of the container. So how can I compare the density of these particles? So what we need to say is that the material which has lower density will float, which has higher density which has higher density will sink in the water, okay, in the liquid. Okay, I'm giving you an example of the liquid here. So I can say that if this one is iron, for example, if this one is iron, okay, the last one is iron on the right hand side. If this one is wood, okay, if this one is a sponge or cork, okay. So what happens is that density of this iron is going to be more than wood. Wood is going to be more than, okay, the cork. If you have any questions, okay, you can just type it on chat. Please, if you have any questions, you can put it on chat and then I can try to answer your questions. So what happens is that the one that sinks has higher density. When I compare these two, which one has more, okay, more percentage under the water, okay, sinks, okay. As you can see, this one is less than half and this one is like almost half, okay. Which one sinks more? That's going to have higher density, okay. That's how we can compare the densities. And the other one, we said that we gave the example of oil and water. Oil floats on water. That's what I'm going to give you in the next slide, okay. If somebody has a question, you can put it on chat, okay. If you have a question, you can put it on chat and then I can try to answer your question. A material which has lower density will float on a liquid which has higher density. For example, oil will float on water, okay. And then I got this example. Maybe I'm also not happy with this example, but it's a clear picture. That's why I use this diagram, okay? So what we need to know is that if you compare the densities of liquids, they don't dissolve in each other. They don't mix with each other, okay? And then what happens is that the one that is low density is going to be up. The one that's going to be high density is going to be down, okay? So if you mix, okay, if you add, for example, syrup, everybody knows what's syrup, and fruit juice, after that water, after that alcohol, you see, you settle for 5-10 minutes, okay? And then nothing mix with each other, nothing move on each other. And then you see that the liquid at the bottom is syrup, is going to have more density than fruit juice. Fruit juice is going to have more density than water. Water is going to have more density than alcohol. The one that sinks to the bottom is going to have more density than others. If you have two, the one at the bottom is going to have more density than one on the top, okay? That's how we can compare the densities of liquids, okay, if they don't mix with each other. There is another one that I want to highlight, discuss, comparing the densities of different materials by hand using identical paper plastic cups, okay? Like a plastic paper cup, foam cup like this, or the cup that you are using for tea, coffee, okay? For example, full of air, okay? What do you do in one of the cups, same size, you fill it with air. How do you? You just move it around in the air, that's all. Second one, you fill it with sand to the top, okay? The last one, you fill it with the flour, okay? That we use to cook, okay? For dough, when you make for cooking, baking, okay? The flour, that's what we are talking about. Flour, sorry, I'm talking about flour. And not each cup of material will have a different mass to that. So what do? You put it on scale. The one that you have air inside, you put it on scale, you check how much is the mass. The one that you have sand, you put it on the scale, how much? The one that you have flour, okay, the one that we use for baking, okay, fill it up, okay, and then put it on scale, you see. And then according to they have the same volume because they are in the same cup, okay. And then what we need to do is that we want to compare their densities. The one with higher mass, what we are expecting is sand. Sand is going to be having more mass, number on the scale. So which means that sand has the highest density. After that, flour has the second highest density, and the last one, sorry, the water has, sorry, water has the second one, but this is what we are expecting. Okay. So, okay. So what we are trying to say is that if you put all of them, okay, fill with the paper cup, okay, or you can try this at home if you want, okay, or the foam cup, you are going to see that the one that you have the sand is going to have the highest density, okay. Why? Because it has the highest number on the scale. It has the highest mass. And after that, we are going to have water. After that, we are going to have flour. Okay. After that, we are going to have air. Okay. So that is how we can use paper cups or foam cups to be able to measure the or compare the densities of different materials. Okay. This is another way. I'm sure this one is an easy one. Okay, you understood this. And today's last point is the oil pollution. That's what we call also as the pollution in oceans. Okay, I like to call it pollution in oceans because the oil pollution, we usually have it in the, mostly have it in the oceans, okay, or water pollution. You want to call it in any other way, okay. And when you search on internet, you can find too many resources about this. You can find videos about this. I want you to watch a video about this, okay? Just do a research on YouTube and watch a video about this, oil pollution. Mixing oil and water to show that oil is less dense than water, okay? So when you spill, okay, when you throw, when you add oil, okay, I'm talking about the oil is the one that's not for cooking purposes. The one that I'm discussing today is the one for producing plastics, producing the fuel that we have. That's what we call crude oil, okay? That is the raw material that we make our fuel and plastics, okay, that we extract from the ground, okay, underground. And it has less density. So if it has less density, what happens? Oil floats on water. And then we are going to read about pollution of water by oil, okay? And then what do you mean by that? Oil spreads under the top of the water and therefore can pollute the large bodies of water. As you can see on the right-hand side, there's a picture. Maybe you cannot see clearly, okay? This is one of the good one that I can find it from internet. As you can see is that this is spilled oil, okay, onto the ocean or sea. And then what are they trying to do? They are trying to remove this, okay? As you can see, it doesn't mix with water. It stays on the surface of water, okay, seawater, okay, and then what happens is that it makes a layer on the top, okay. So what are the effects on the environment? That's what I want to read about. I found a good text about this. That's what I want to read, and I want to show you some accidents, okay, names, especially in South Africa. We had some in 2019, and I'm going to show you there is a list of the oil spill, oil pollution around the world, okay. I would like to show you that. Oil spills have occurred many times each year since 1970s. In 1967 is the first one, if I'm not mistaken. It's on the record. And learn what causes these destructive and deadly accidents, how they affect the environment, about some of the infamous oil spills of all the time. What are oil spills? Have you ever made a mess that was so bad that you didn't even know where to begin in order to clean up? Yes, very, very hard to clean this. It's not an easy job. You need to spend lots of money. You need to have lots of people to do this, and you need a long amount of time. You are not alone. This happens all the time to the environment during an oil spill. What's an oil spill? An oil spill is a form of pollution, harmful and poisonous things, okay? Especially the crude oil, especially I'm talking about fuels and crude oil, okay? And is there oil spill for the cooking oil that we have? Yes, that's also, okay, that's also there. It is not good to throw your oil to the sewage, okay? You have to keep it in a container, and then they can recycle that. It's possible to recycle in different forms. That people put into the environment. Oil spills usually happen in the ocean. Why? Because we usually transport oil through the oceans from one continent to the other one. That's what happens. But oil can spill on land as well. Yes, it's possible to have on land. That's also lots of problems. That also will give us lots of problems. Very hard to clean up. And these spills cause many devastating, effects, mainly animals. Yes, but also plants and to the people. Unfortunately, oil spills happen quite frequently. Okay, it's not something happens once in a year. I'm going to show you some examples now. Causes of oil spills, although there have been oil spills as far back in 1908. Okay, it happened. They really okay, but after the most of the record is after 1960s around that. Okay, started to happen more frequently in the 1970s. Oil is used across the world for many things, including making plastic items. Yes, and is for people's in car, any kind of fuel that we are using for ship. Okay, for example, the fuel for the planes, fuel for any kind of machinery that you use, okay, like diesel, okay, etc. Because so many people use it all over the world, oil is transported in huge tankers, okay, and which are giant boats, okay, but these can leak. Yes, it might be oil spill because of the leak on these giant boats. The crash, okay, they can crash the land, they can crash with each other, and there might be explosion, okay, and because static electricity, because this thing is flammable, static electricity can cause an explosion. It's easy to have an explosion on these things, okay, static electricity. Okay, if you want, you can do research on this. I'm not going to go into details. Causing to oil to spill in the ocean. There are other ways oil spills can happen too, like when people actually dump oil into the sea. This is illegal. Not You are not supposed to do that. Drill for oil in the sea. If you drill, you have to clean up. Yes. And when their boats and the jet skis, okay, leak oil. Okay, if you are using a boat, if there's a leak, you have to look after it. Effects of oil spills. Okay, this is generally. I'm not going to go into details. Oil spills are extremely damaging to the environment. The shiny substance. Usually, this oil is shiny. It creates a shiny black surface. Okay, not transparent surface that forms on the sea, and when oil spill causes many marine animals like seabirds, okay, when they go onto this shiny substance, okay, it can stick to their body, and then they cannot fly, they cannot move, they can stick to the water, and then they will die. Sea otters and killer whales and then get sick and they can die if they get this into their bodies. Many marine plants under the water, around the water as well. The oil creates a thick layer on the top of the water that does not allow light to pass through, and the the life under the ocean will finish. So the plants are unable to survive because they need sunlight, they need oxygen, they need, okay? And the oil can make people sick, yes, especially if it gets into the seafood. Yes, they can get, but it looks like the normal fish. How do you know that there is inside, okay? And that people can eat, such as shrimp, okay, shrimp and the fish. And then I would like to share something with you before you go, okay? Can I just show you something before you go? Okay, I'm just going to share something with you. Okay, I'm just getting the attendance now. I'm getting the attendance now. So with your permission. So we said that if oil spills, it does not affect only the animals inside. It affects animals around it. It affects the plants around it. It also affects the humankind, okay, getting their food or doing their job on it, okay? That's also important. So when I click on this, okay, maybe you can see on your screen, okay, you should be seeing on your screen, okay, if you just search on internet, you see the list of oil spills. That's what I found. These are the ones recorded, as you can see, and the latest one is 14 June 2020, okay? And it's around 118 tons of oil spilled, okay? And it's in Canada, okay? And then there is New Zealand, USA, I don't know why it is doing like this, okay? There's one in South Africa. I just wanted to show you this. August 2019. How much spilled? We don't know, unknown, okay? 2019, the latest one in South Africa. And before that, July 2019, oil spill, another one, okay? It's in Algoa Bay, okay? It's in Algoa Bay, around this side, and it's around almost like 0.2 tons, okay, spilled. And if I go down, I'm just looking at the South African ones, okay, you can see others. Just going down, down, down. I cannot see the flag. I'm just looking at our flag here. Yes. And June 2000, okay, before that, June 2000, 1,400 tons spilled in Cape Town. Can you see that oil spill? And before that, I'm just looking, going back, Cape Town, another one, 1994, 2,400 tons spilled in Cape Town, around Cape Town. And then if I go, there's one in Mozambique, 72,000 tons in 1992. And these are huge numbers, as you can see. And South Africa, East London, 1989, 10,000 tons of oil spilled, okay? And as you can see, there is more. And if I just want to show you the first one is in record here, is the 1903. It's in Australia, United Kingdom, UK, 1907. Okay, it starts from here, and there's a list here. If you just search on internet, list of oil spills, that's what you can see. When it is, which company was responsible for this, and then responsible for this, and how many minimum, how many maximum tons spilled, etc. And then if you want to do a research about this, just write oil spill, and then you can find there's too many resources about this, okay?